So we already have said, see, this is the language you need to use in writing. Okay, in exam, like you have to consider an atomic system having two energy levels. You can define the energies as well as the number of particles to the respective levels. Okay, that's what we have done is, and similarly, you can write the rates for this particular process, and that also we have written and we have understood in the last lecture. So similarly, you see, you can write in this manner, and we are knowing that B12 equal to B21. That is why this W12 we are writing equal to W21. Fine. So this is all we have discussed. And whenever you write about this two-level system or maybe three-level system or four-level system, whatever in exam, you please make this diagram like this. This is for two-level. For three-level, it may be different. For four-level, it may be different. But when you make a diagram, then things are going to be more clear. Okay, so let me move it further. So here you see the second process again for spontaneous transitions. We have discussed this also. T21 is basically the sum of A21 plus S21. Let me remind you one more time. A21 is for the radiative process. Okay, S21 for the non-radiative process. Radiative process is the same in which photon is going to be emitted via the process. S21, that means non-radiative process in which photon is not going to emit. The only way is the amount of energy is going to be exchanged with the surroundings. Okay, but keep in mind the probability of happening this A21 is very very large compared to S21, and that is why many of the time we are skipping this S21 because the number of this S21 is very less compared to A21. So directly we can write T21 equal to A21, but since we are in the process to derive the outcome, the result, that is why we have included all such small factors also over here. Okay, let me move it further. So that's how we can write the rates. Again, I am emphasizing on the content. I told you in the last lecture also that whenever you write for the rates for the two-level system or for the three or four level, we are going to see. But always try to write the rates for the upper level first. So here in two level, the upper level will be level number 2, and that is why first I have covered. Let me annotate it. Okay, so that is why I have written for the level 2 first. Okay, rate in the sense whenever I say rate, that means I am talking about the number of particles per unit time. That is why dN2 by dt. We need to see how, with respect to time, how number of particles are changing in each level. So first I will write for the level 2, and this is how we arrange all such terms. I have given you the idea how we got it. Okay, it is simply the funda of credit and debit. So whatever the amount you are going to lose from your side, you have to put that quantity in minus sign. But if someone is getting that amount, that person has to use plus sign for the same quantity. So that's how we can write these terms, and these terms are nothing but basically all the three process rates which we have discussed in the earlier slide. So you place it one by one depending on which level is gaining, which level is losing, and this comes out come to be very simple. Okay. So similarly you can write for dn1 by dt also. So that's how you can write it. Okay, and at the end, if I say to you people that whatever you do credit debit, okay, your total has to be like zero. The sum has to be zero, so that whatever the entries you make on one side, it has to equal with the another side. So that's how we do in this level 1 and level 2 case. And if you do the sum of these two now, dn1 by dt plus dn2 by dt, okay, so now you see it is clear. Let me, yeah. So now you see on the right hand side, if I take the sum of these two, you can write in this format also d by dt of n1 plus n2 equal to 0. Now if you integrate it, so you know very well, if you integrate it, then you will get a constant. And let me define that constant as capital N, or somewhere in some other book they are writing as capital M naught also. Clear? So, and that is the reason many times we are saying that the total number of particles in a given system, be it 2 level or 3 level or 4 level, doesn't matter. But in a given system, the total number of particles are always going to be a constant number. Okay. So here we have only 2 levels. That is why n1 plus n2 is equal to constant. But suppose if we have 3 level, then you write one more term n1 plus n2 plus n3. That also is going to be a constant number always. So that is the proof which we are obtaining from this 2 level system. Same thing you can apply for 3 level also, you will get the same result. Okay, so this is the general thing you say, you can generalize it also. And let me move it forward. This is one result which we are getting from this 2 level system. Another result is, you see on this, let me remove it out every this side. You see. So now we are going to consider a case, okay, of steady state. Let me annotate one more time. This is the important case, steady state. Now, when I say steady state, that means it does not, I mean, the number of particles does not depend on the time. So you see this vector dn1 by dt. If your number of particles are not depending on time, it is not changing with respect to time, then of course this dy dt vector will be zero. Okay, this is the simple mathematics. You all know very well. If something is not changing with respect to the denominator side, then the quantity is going to be zero. So that is how in steady state, that means both the upper level particle as well as lower level particles are not changing with respect to time. That means you will get zero. Okay, so zero equivalent with dn1 by dt also, dn2 by dt also is equivalent to zero. That is why in this format you can write it. Otherwise, you can write it separately also. No need to worry about that. Now, if you place this result dn1 by dt equal to 0 or dn2 by dt equal to 0 in the earlier formula which we have derived it for this and for this, okay, you place the value of 0 instead of this term. That means on the left hand side, let me move it to the this one here. So at steady state, as I said, dn1 by d2, dn2 by d2 dt and dn1 by dt both are 0. So you put 0 on the left hand side and try to simplify this part. Okay, you simplify it, you make it simple. Okay, so what you will get it, you will get this term. Okay, let me annotate one more time. Yeah, so if you put this equal to 0 and you simplify both these terms, okay, you will get a quantity like this, that is n2 by n1 equal to w12 divided by w12 plus t21. Now let me explain you one more time. What is n2? N2 is the number of particles, number of atoms in the upper level, or let's say level number 2. N1 is the number of particles or atoms in the level number 1, or you call it as the ground level also. And on the right hand side, you see W12. This W12 T21 is nothing but the probability again, as we have discussed earlier. So this W12 is the probability of happening the process for stimulated absorbing process, because W12 is there. Okay, this is also same because we have known that these probabilities are equal. So you can write W12 also, not to worry with that. It is simple. And this T21 for the spontaneous process, which is happening from level 2 to level 1. So basically, these are the probabilities as I am claiming over here. Now you see, in any case, can you get n2 larger than n1 from this formula? You just look it out carefully. In any case, are you able to find out any particular case in which this n2 can be larger than n1?
No, sir.
Right? It is not possible. Why? Because if you see on the right hand side, this vector is already large. It is the sum of these two. Okay, even though if I consider, let's say W12 is very large compared to T21, so you skip this also. There also you see this will cancel out. That means it is equivalent with 1. That means N2 can be equal with N1, but N2 cannot be larger with N1 with this formula. Another thing is someone say, okay, what about if I say negative numbers? Okay, W12 I can keep in minus sign or something. So let me tell you that these are the probabilities, and we know that the probabilities cannot be negative. Okay, so all such cases in which this particular case can be possible, right? That if I do this, so it can be a negative or something. This n2 can be larger if I use this minus sign or here something. Or this I instead of plus, if I put minus because of this probability. So let me tell you that this again I am repeating, probability cannot be negative. So because of that, if you try all such arrangement in this formula, what we get is the maximum we get is n2 can be equal with n1. And that too, when I consider that this W12 is very large compared to T21, that means the stimulated emission process is very large compared to the spontaneous process. So in that case, only this N2 can be equal with N1. Okay, but in general, if this T21 factor is also there, then this N2 is always less than. Clear? So that is how this is the solid proof. On the basis of that, we are claiming that two-level system cannot be useful to generate the laser light, because we are knowing that for generating a laser light, we require N2 larger than N1. That means upper level particle must have large number compared to the lower level. Second criteria, that stimulated emission has compared to any other. So you see this first criteria itself is not fulfilling in this form, and that is why this two-level system is not able to generate laser light. Okay, so this is how the mathematical proof for that. So, and how is it possible to get this result? Because of rate only, rates equation, which we have discussed the importance earlier slide. So rates are really, really very important because like we have done it over here for the two level system. Same thing you can do for three level system also as well as four level system also. So what we are doing is since this three level, I mean this two level derivation part is there in your syllabus, but for the three level and four level, the derivation is not there in your syllabus. But I will make it, I will go through it quickly so that you can understand that yes, the same thing can be applied to three level as well as four level also. So remember, three level, four level are there in your syllabus, but this derivation of this formula kind of thing will not be there. Okay, otherwise theory part will be there of three level and four level. So no need to confuse. Let me go through it again. The next part. So till now we have seen that two level system is for just basic understanding. It is not required for generating the laser light. So now what is the alternate solution for that? Now you can go for the higher level, that is the three level system. And that is how you see on this, on the right hand side, the diagram will be there. Okay. And again, if you look at the wording, how to write into the exam something. So then you see wordings are very simple again. That again you consider an energy energy system, okay, or atomic system having three energy levels, okay, and then you can write the someone is speaking. So what you do is you always you write down like consider an atomic system having three energy levels. You write down the energies as well as the number of particles also correspondingly. So that's what I have written over here: E1, E2, E3, N1, N2, N3. Someone please mute your mic. Okay. So here it is N1, N2, N3 that represents the population densities or the number of particles. Whatever way you write, you can always write it down, whichever is requirement. Okay. And then you see over here this pump, etc. All such things. Now what we have to do is, as in the earlier task we have done, that we need to supply the energy from the external source. Okay. So that is how. Let me annotate it. So this is the energy. How it can be possible? We have to take the help of pumping source, the pumping mechanism. Okay. So now we are supplying this energy.
Consider.
Sorry, can you repeat it?
Which pumping is considered over here?
No, this see it all depends on the type of material you have, because already we have discussed what kind of pumping can be useful for different systems, different materials. So at this case, three level, I assume that now we are taking the solid material. So for the case of solid, you can go for the optical pumping. But let's say if material is in gaseous form, then you can go for the electrical pumping. Okay.
Electrically.
Yeah. So here I just consider a simple case that pumping is there. Now it all depends on the type of material. Okay. So we are going into depth also. No need to worry. But this is the general principle we are following over here. Okay. So you need to consider a pumping source. Okay. So that you can provide the energies. And now look at how much energy you want to provide so that the particles, the atoms which are there in this lower level or in the ground level, they can absorb it and reach directly to this third level. Okay. Now let me tell you the other scenarios also, because then only you will understand the proper picture of this three level system. Now, even though you are supplying this much amount of energy, but chances are there, because we are dealing in the quantum world. So chances are there that some of the atoms may absorb the energy but reach up to only this level number 2 only. It will not go up to level 3. But again I consider, okay, again I assuming that majority of the number of particles, if they absorb this much amount of energy, they will reach to level number 3. Okay, but you cannot deny the probability that they cannot extract at level 2. Chances are there, but since to find out the outcome from this three level system, we are considering that almost all the particles or the atoms, after absorbing this amount of pumping energy, they will reach to the upper level, level number 3. Okay, but remember, it is not that two level, I mean, particle cannot reach to the two level. It can also be there, but the probability is very less. So we are neglecting this part. Okay, so we assume that whatever energy you supplied, it absorb it and directly reach to the level number 3 over here. And now here in this sense, in this part, you see the energy and this number of particles I have written. Energy is over here, E3. Number of particles, let's say N3. Okay, and So the particles are there in this level as an excited form. Okay, and now you people are knowing that we have discussed so many times that whatever the things are there in the excited state, it cannot be there for a longer time. It has certain lifetime after which it has to come down to the lower level. Okay, so here in this part, okay, the particles which are already excited, the lifetime of this level 3 is very less. Okay, and that is around, let me write it down, that lifetime is around 10 raised to minus 8 seconds. Okay, that means after spending this much amount of time interval in the level number 3, that excited particles have to come down to the lower level, and that is why, since the time interval is very small, you see 10 raised to minus 8 second almost, so that decay is going to be considered as rapid decay, because this process is going very fast. After spending only this much amount of time, immediately they will decay from level 3 to level 2. That's how they have you can see over here. Okay, and this kind of that rapid decay will be non-radiative one. Okay, because the time interval you see it is very less. Okay, so that kind of decay basically is non-radiative decay. So in which only, see, whenever the decay is going to be there, some amount of energy is going to be emit. So the probability, of course, spontaneous process photon can also be emitted, but the chances are very less because of this time interval. Okay, so we consider that it will emit some amount of energy and then in form of heat, and then it will come to the level number 2 over here, which you see. Fine. Now here the important thing is the lifetime of this level 2. Okay, the lifetime of this particular level 2 is high compared to this one. Okay, and how much it is? Let me give you the rough idea. The lifetime for this level 2 is around 10 raised to minus 3 second. So you see this amount is very less, 10 raised to minus 8 second. This is comparatively large compared to this. Okay, so that means after coming to this particular energy level, level number 2, since the lifetime is more, you see 10 raised to minus 3 second is large compared to this one. So the lifetime is more. So that means that particles which are still in the excited state compared to the ground state, you can see easily energy difference. So they can stay for this much amount of time interval over here. So now what happens in this case? So particles are coming from level 1, reaching to level 3. Immediately they will come to level 2. Here in this case, because of high lifetime, they are getting accumulated. That means the number of particles are getting increased in the level number 2 in this part. Okay, but at the same time, this pumping from level 1 is going on continuously. So what happens actually in this whole process? This pumping is going on, this process is going on. So because of that, the number of atoms from level 1 is getting reduced. But here in this level 2, the number of particles are getting increased because of this lifetime. So with this arrangement, we are able to achieve N2 greater than N1. Okay, and don't confuse with this N2 N1. Simply you write N for upper level is larger than N for lower level. So this is your lower level, and this will be your. Let me clear it out everything. Then you see. Okay, so what happens? This pumping is going on. Okay, so number of atoms from ground levels are going to be reduced. Okay, but at the same time, after spending few time, it will come to this level 2. Here the lifetime is more, so because of that, their numbers are getting increased in this part. So basically, N2 is going to be large, and here N1 is getting less and less because this pumping is going on, and that is how you can achieve this criteria N2 larger than N1. Okay. Important thing from this is, you see this, the amount of energy which you are supplying is very large. You see it is in terms of h nu p. Nu p is the pumping frequency. Okay, and with this you see the interval also, this much high energy we are supplying, this much energy difference you consider. Okay, but at the end you see the output is less compared to the incident energy. Only this much amount of energy difference we are getting as the output of laser beam.
અરે તોડ્યું નહીં હું પેલું ડબ્બુ કાઢવા ગયો ને તો બહાર આવી ગયો દરવાજો કોઈ લૂઝ હતો આમાં
भाई प्लीज म्यूट करके रखो अपने माइक्स. Okay, otherwise I need to make it every time. Now look at here, important which I was talking. You are supplying this much amount of energy nu p, which is up to the energy level difference between level 1 and level 2. But here you see this one. Okay, laser output, which is from level 2 to level 1, and you see the energy level difference. It's very small compared, I mean, it is small compared to the incident energy which you have supplied. That means, for example, I will give you the idea. If you are supplying 10 electron volt energy, okay, over here in the starting, then of course this particular laser beam which is emitting from this 2 to 1, okay, it has the energy less than 10 electron volt. Okay, depending on the energy level difference, but it is very clear from the diagram that the energy which is coming out from this laser part, it has to be less than 10 electron volt, because as you can see in the circuit diagram, it's very clear. Okay, so have you got the idea? What we are doing is, the purpose of generating laser light is, I mean, the requirement for generating the laser light is upper level must have large particles compared to lower level. That's what we are going to achieve in this. Okay, how we are achieving? We are achieving through this pumping also. We are supplying it, no doubt, and that's how you get the laser light from this. So, any doubt in this?
Sir, here rapid means a jump from third to second level, right?
Yes, third to second.
How the particles are more in third level, they will directly jump to second and ultimately to first.
Yes. No, but starting procedure, you say you are supplying very high energy, because of that all can reach to the upper level first. Okay. So this is the process. You are supplying maximum energy so that it can directly reach to the level number 3. Okay. And there, since the lifetime of that level is less, so they cannot spend more time in the level number 3. Because of that, they have to come down to the lower level, that is level number 2. And there the lifetime is large. That means they can stay for more time in this level 2. And that's how we require that level 2 has to be more number of particles compared to the level 1.
Sir, in two-level system, if we supply more energy, then this should happen. No, because level 2 is
No, you are okay. There is some confusion, because in last time also someone is having confusion. So let me clear it out. In two-level system, when I say two levels are there, it is just the probable levels. Okay, it is not fixed. So when you supply the amount of energy, accordingly the upper level will be decided. Suppose if you give 10 electron volt, so upper level will be 10 electron volt over here. Suppose if you give, let's say, 50 electron volt, so that upper level or second level will be at 50 electron volt energy level.
okay, so it depends on energy which we supply.
Yes. So it is not like these energy levels are fixed and then you supply, suppose this apart from this 10 you give 50 to upar jana chahiye. No, these are the probable levels we are considering for the two level. So the amount you supply at the beginning, according to that upper level will be decided in the case of two level system. Okay. But
Yes.
yeah, so now it is clear. Many people have the similar doubt, like what if I give more than the incident, like 10 के बजाय मैं 50 इलेक्ट्रॉन वोल्ट दे दूं तो उसको तो ऊपर जाना चाहिए. नो, वो फिर अपर लेवल 50 पे सेट हो जाएगा. Clear? So ये जो रैपिड डीके है, because टाइम इंटरवल काफी कम है, so only the spontaneous process can be possible. In case of spontaneous only, majority basically यहाँ पे आपका एमिटी होता है हीट के फॉर्म में इतने कम टाइम इंटरवल में. But sometimes photon के भी chances है, because it's a random process. We don't know anything. So that is how your particles will emit and come to this level number 2. So still, yeah, please.
Sir, 3 and level 2 is light from there too, right?
Some two light. Your voice is a little bit breaking, so I was not able to hear properly. Can you repeat again?
Yes. Is it cracking now?
Yeah. No, it is perfect now. You please.
How can we be sure that when the rapid decay occurs between levels,
Yes.
it's always
No, see, that's what I said. The probability of happening all such processes are there. Okay, you cannot deny that, and you cannot claim that only radiative is happening, non-radiative is not happening, something or either way. What I'm saying is the lifetime of this level is very less, of 10 raised to minus 8. Okay, so because of that, what happens is the particles cannot stay in the higher level. Okay, so they need to go down immediately, because this lifetime is very less. Immediately they need to go to the level number 2. Now this time interval is so small that the chances of emitting the spontaneous photon, okay, is less. But at the same time, if you see, if energy level difference is coming out, that means some amount of energy is going to be lose in the system. Okay, so how it is going to come out? It is coming out in form of heat, and that can be exchanged with the surroundings. बट फोटोन के निकलने के भी चांस है, बट इतने नहीं है कंपेयर टू की जो रैपिड डिके में, क्योंकि उसके लिए थोड़ा आपको टाइम बिल्ड चाहिए रहता है. 10⁻⁸ सेकंड टाइम इज इंटरवल इज वेरी लेस. ओके, सो प्रोबेबिलिटी उसकी काफी कम है. आई एम नॉट सेइंग कि प्रोबेबिलिटी है ही नहीं, बट इट इज वेरी लेस कंपेयर टू दिस हीट फॉर्म. And that is why, and in the diagram you see this energy level difference this much large, but in practice it may not be this much. Okay, this energy level difference I created just for your understanding purpose. Okay, so in actual there are so many differences are there. This is the theoretical model basically. That's why this circuit diagram will be like this. But in practice, this energy levels 3 and 2 are very nearby. Okay. So this is clear. Any other doubt?
Sir, every time this laser will be emitted from second to third level only, or second to first level jump only?
In 3-level system, it is second to first, but in 4-level system, again the scenario will change.
Then it will be from third to first, right?
No.
Then
Third to first will not be there. Always remember, whatever the light or signal is going to be emitted, it is by the consecutive layers only. Okay, so it may be possible 3 to 2 or 2 to 1, but you cannot expect 3 to 1. Okay, डायरेक्टली जंप नहीं होगा, वो स्टेप बाय स्टेप्स में आपके सारे आंसर्स होंगे. चांसेस रहते हैं नो डाउट, बट जो प्रोबेबिलिटी है ज्यादा होने की वो कंसेक्यूटिव जो लेवल से पास जैसे 3 से 2 हो गया या 2 से 1, वहां पे उनकी प्रोबेबिलिटी ज्यादा रहती है. ये अगर आपने एटॉमिक फिजिक्स थोड़ा डेप्थ में जाओगे, देन यू विल क्लियरली अंडरस्टैंड कि किसकी प्रोबेबिलिटी ज्यादा होती है, किसकी कम होती है. But no need to worry. Again, we'll discuss when we are going actually into the system part. Laser systems, when we discuss, that time I will give you the idea why 3 to 1 cannot be possible or something, some other systems. Okay, we'll discuss.
okay, sir.
Yeah. Someone is asking for the pulse light. Yes, the outcome from we get from this 3-level system. Basically, it is in form of pulse only. So all such things will
Sir, it
discuss.
will be collimated, right?
Yeah, collimated.
Okay.
So still, if you have any doubt, let me take you one more example that will clear your all sort of hurdles or problems or doubts you may have. So you people are going to the school, okay, up to this level. Before coming to the university, you always get to the school, and maybe those who are saying that they have taken the admission in the dummy school, so no need to worry. But at least up to 10th, you went to the school, right? So let's consider that case. So what happens many a times, you may be thinking, right? Let me speak little bit in Hindi so that you will be familiar with that example very clearly. So आपको स्कूल जाना रहता है डेली, है ना, राइट? आपका टाइमिंग में भी सुबह सुबह 7 बजे और 8 बजे समथिंग. लेट्स कंसीडर कि अर्ली मॉर्निंग में आपका टाइम है स्कूल का, एंड यू नीड टू गो एवरी टाइम, डेली आपको जाना ही पड़ता है रेगुलर. तो तब तो लॉकडाउन जैसा कुछ था नहीं, तो आपको फिजिकल क्लास अटेंड करने ही पड़ते थे, राइट? सो नाउ यू सी, कई बार ऐसा भी होता है कि आपको स्कूल तो जाना है लेकिन आपका मन नहीं करता, राइट? एंड दिस हैपेंस वेरी फ्रीक्वेंटली, राइट? बिकॉज इन स्टूडेंट लाइफ दिस इज द वेरी सिंपल थिंग व्हिच हैपेंड वेरी फ्रीक्वेंटली, कि कई बार मन नहीं होता है कि यार स्कूल आज नहीं जाना है, बंक मार देना है, समथिंग व्हाटएवर इट मे बी. तो लेट्स कंसीडर द सेम केस. ओके, कि अगर आप अर्ली मॉर्निंग में हो, आप अर्ली मॉर्निंग उठे हो और आपको स्कूल जाना है, बट समहाउ आपका मन नहीं कर रहा है, राइट? आपका मन नहीं कर रहा है, दैट मीन्स कि आप अभी भी अपने घर पे ही हो, कंफर्ट जोन में हो, आप आपके बेड में. सो लेट्स से वो जो कंफर्ट जोन है आपका घर में, जिसमें आप आराम से हो, सोए हुए हो या बैठे हुए, व्हाटएवर भी, सो दैट विल बी योर ग्राउंड लेवल. ओके, दैट मीन्स कि आप अभी लेवल 1 में हो, जस्ट आप उठे हो और आपको अभी प्लान करना है. हो सकता है कि आप ना भी जाओ, एंड सडनली आपके हाव भाव देख के, आपके चेहरे के एक्सप्रेशंस देख के, आपके जो पेरेंट्स है, आई अज्यूम कि आप आपके पेरेंट्स के साथ में ही रह रहे हो, तो आपके जो पेरेंट्स है वो इस आइडिया को उनने पकड़ लिया कि यार आज जो है आप बंक मारने का प्लान कर रहे हो, स्कूल से मारने का प्लान है आज आपका. So they somehow come to know about this plan. So what they will be doing is their role will be like pumping. Okay, so your parents will guide you or may force you also. Sometimes they counsel you, know that you need to go to the school. Okay, something, whatever. So whatever the amount of counseling, guiding, forcing they do, your parents do. Basically, this is the type of pumping only. Okay, as I said, pumping is always different. Same way for all of you, the pumping pattern may be different. किसी को फोर्स करके बोलना पड़ता है, किसी को गाइड कर दो तो भी समझ जाता है, किसी को प्यार से समझा दो कि नहीं बेटा स्कूल जाना जरूरी है, आपके पेरेंट्स अगर ऐसे समझा दे तो वो डिपेंड करता है कि आप कौन से वाली पंपिंग के लिए सुटेबल हो. अकॉर्डिंगली यू विल गेट द पंपिंग फ्रॉम योर पेरेंट्स, दैट अमाउंट ऑफ एनर्जी. ओके, एंड नॉर्मली आई कंसीडर कि जो आपके पेरेंट्स थे वो इनफ इनपुट उनकी तरफ से प्रोवाइड करते हैं. सो सपोज दे हैव गिवन द प्रॉपर एनर्जी, प्रॉपर पंपिंग फ्रॉम देयर साइड, उन्हें प्रॉपर पंपिंग किया आपको, है ना. एंड समहाउ आप कन्विंस भी हो गए कि हाँ जो मेरे पेरेंट्स बोल रहे हैं दैट इज फाइन, वो सब कुछ सही है. 90 to 95% केस में आई कंसीडर कि अगर आपके पेरेंट्स आपको समझाते हैं, गाइड करते हैं, देन यू विल बी लाइक ओके ठीक है फाइन. वो मन नहीं होता आपका, अलग बात है, बट आपके पेरेंट्स ने आपको समझाया, फोर्स किया, गाइड किया, यू विल बी एग्री. यानी कि आप उन्हें पंपिंग दिया, आपने एब्जॉर्व किया, you will be getting ready for that now. Okay, but again there are some probabilities. As I said, everything will be depending on the probability, and you cannot deny that this thing cannot be possible. Probability is always there for everything. Okay, so there are few cases I consider not more than 5% something. So some of the cases will be like they are getting the pumping from their parents, and again I am focusing on the word that the pumping which your parents are giving to you is proper. There is no fault from their side. Okay, they are doing their job perfectly, but somehow you are not able to get that pumping energy properly, right? That means अगर आपके पेरेंट्स ने जितना आपको पंप किया कि आप स्कूल तक चले जाओ, लेकिन अगर आपने उनकी बात तो मानी कि ठीक है मैं रेडी हो रहा हूँ, मुझे जाना है, बट अगर वो पंपिंग प्रॉपर नहीं हुआ तो व्हाट मे हैपन, समवेयर अगर आपके रास्ते में कहीं पीवीआर आ रहा है या कुछ और मॉल आ रहा है, देन यू विल बी स्टक ओवर देयर. इंस्टेड ऑफ गोइंग टू द स्कूल, आप आपके व्हीकल से जाते हो, तो आप घर से तो निकले हो स्कूल का ले बोल के, यार आपके पेरेंट्स ने पंप किया तो आप स्कूल जाने के लिए रेडी हो, बट आपका माइंड तो कुछ और भी, आपका माइंड कुछ और ही सोच रहा है. जो आप स्कूल ना जाके बीच में कई सारे हेडल्स आते हैं, जैसे मैंने बोला पीवीआर आया या कुछ और भी जहाँ आपको जाना हो, तो वहां जाके आप रुक गए, दैट मीन्स वो आपका लेवल 2 है. ओके, तो इसीलिए मैंने आपको बोला था कि चांसेस किसी भी चीज के नहीं, आप बोल भी सकते हो कि नहीं होंगे, चांसेस आर ऑलवेज देयर. एंड अगेन आई कंसीडर दैट आउट ऑफ 100 95% केस में आप एनर्जी लेके सीधे स्कूल पहुंच जाओगे, यानी आपके पेरेंट्स को काउंसलिंग लेके. बट फ्यू केसेस में यू विल बी देयर एट द लेवल नंबर 2, वो पॉसिबिलिटी भी है. ओके, नाउ यू फॉरगेट दैट केस कि वो जो है वो 2 पे फंसा है तो फंसे रहते हो. नाउ कम टू दिस लेवल 3. So I assume here pumping is proper, so because of that you reach to the school. Okay, now what happens is, suppose आपका जो क्लास है वो let's say 7:30 से start होने वाला है, fine, and then what will be there in this, if 7:30 is the time, okay, and आप suppose 7:15 पे पहुंच गए स्कूल और 7:20 पे पहुंच गए, so you may have 10 to 15 minutes free with you people. ओके, समटाइम्स होता है ना, कई सारे अलग अलग स्कूल के लिए वेन्स आते हैं, अलग अलग जगह से आती है, सो इट में टेक सर्टेन टाइम टू रीच ओवर देयर. तो यू टेक द सेम एग्जांपल, तो आप 7:20 पे 7:15 पे पहुंच गए, बट आपकी क्लास 7:30 से है, तो यू हैव सम फ्री टाइम. ओके, दैट इज व्हाट यू आर इन द लेवल नंबर 3, हैविंग सम फ्री टाइम. व्हाट हैपेंस आफ्टर दैट, द मोमेंट योर क्लासेस आर गोइंग टू स्टार्ट एट लेट्स से 7:30, इमीडिएटली यू कम टू द दैट फ्री जो एनवायरनमेंट था आपका, जिसमें आप रोम कर रहे थे स्कूल कैंपस में, गार्डन्स में, नाउ वो 10 मिनट का टाइम इंटरवल था. ओके, नाउ यू विल कम टू द क्लास एट 7:30, दैट इज योर लेवल नंबर 2. So that is why now you can relate it that level 3, why level 3 has less lifetime. Okay, because the 10 to 15 minutes, of course it has to be more, but you people have to attend the class because for some purpose you are coming to the school, so that is why. So this level 3 always has a less lifetime. Okay, here it is 10 raised to minus 8 seconds, but in your case it may be around 10 minutes something. Then you come to this level number 2. Okay, now here you know, of course, since you are attending the school, so now you know that at least 5 to 6 hours you need to spend. Okay, so level 2 is, I mean the lifetime of level 2 is large compared to level 3, क्योंकि जो आप 10 मिनट घूम फिर पा रहे थे स्कूल कैंपस में जल्दी आने के बाद, लेकिन एक बार क्लास में आने के बाद आपके 4 से 5 लेक्चर कंटिन्यू हुए, दैट मीन्स आपका जो लाइफ टाइम है क्लास का, तो लेवल 2 का, वो काफी बड़ा है. ओके, सो आई अज्यूम कि 4 से 5 घंटे का जो लाइफ टाइम है वो आपका लेवल 2 है, एंड देयर यू नीड टू स्पेंड लॉट ऑफ टाइम. Okay, and once after spending this much amount of time interval, okay, again you want to go back to home. तो जब आप इतना टाइम स्पेंड करके घर जाओगे, तो then you see, मतलब कि लेवल 1 अगेन level 1 is nothing but your home or the comfort zone where you want to reach again. So after spending 4 to 5 hours in level 2 in your class, you will go to the home again. But when you go to the home from the class, from the school, you take certain knowledge with you. बिकॉज आपने 4 से 5 घंटे में जो भी पढ़ा है वो आपका नॉलेज है जो आपने गेन किया है स्कूल के अंदर उस टाइम के अंदर उस लेक्चर के अंदर एंड दैट इज व्हाई वी आर राइटिंग वी आर कंसीडरिंग एज ए लेजर आउटपुट okay here this is laser output same thing you can also consider whatever the knowledge you have generated from the lecture or you have taken from the lecture that will be considered as the output when you go to your home so that's how this whole system is working so this is the 3 level system useful for laser same level system is working for you people also and you are following it and that is why I told you many times physics is not the thing जो आपको रटना पड़े याद करना पड़े physics is basically you just relate with something आप किसी भी चीज से रिलेट कर लो ये मैंने आपको डेली लाइफ के एग्जांपल दिया नाउ यू कैन इजीली रिलेट हाउ डेली लाइफ कैन बी इंटीग्रेटेड विद दिस 3 level सिस्टम ओके सो अगर आप 2 से 1 में आते हो जब आप स्कूल से घर में आते हो कुछ नॉलेज आपको मिलता है दैट इज परफेक्ट ओके वो आपका लेजर जनरेट हो गया बट देयर आर केसेस आल्सो समटाइम्स कि आपने पूरा टाइम स्पेंड किया लेकिन आपका ध्यान और फोकस नहीं है क्लास के अंदर देन आपका लेजर एमिट भी ना हो ओके तो चांसेस आर देयर फॉर एवरीथिंग So that is why make sure whenever you attend the class, अब स्कूल तो चले गया लेकिन आप यूनिवर्सिटी लेवल पे हो, so whenever you attend the online class, at least you focus on the content properly, so that आपका जो आउटकम है इतने सारे घंटे डेली अटेंड करने के बाद वो कुछ निकले, okay? And remember this pumping energy. Same way you can consider in my case also. So मैं जो आपका काम है वो क्या है आप ग्राउंड लेवल पे हो मुझे यहाँ से एनर्जी सप्लाई करनी है थ्रू दिस लेक्चर थ्रू सम एग्जांपल्स व्हिच आई एम गिविंग टू यू तो मैं पंपिंग एनर्जी मेरी साइड से दे रहा हूँ बट कितने लोग लेवल 3 में जा रहे हैं कितने लोग लेवल 2 पे अटक गए पता नहीं वो आपको ही पता है बट आई होप कि आप लेवल 2 पे आके हो जाओ कंटेंट को प्रॉपर सुनो और जब आप वापस जाओ ये लेक्चर छोड़ के तो एटलीस्ट कुछ आउटपुट आप लेके जाओ कुछ आउटकम आप लेके जाओ दैट विल बी योर वर्क समथिंग कुछ आउटपुट आपको मिला लेजर राइट आपका जनरेट हुआ यू कैन से okay so that's how this whole process is working but अगर आपको कुछ नहीं समझ में आ रहा है राइट या कुछ आपका ध्यान कहीं और है और आपका लेजर आउटपुट या कुछ आउटपुट नहीं निकल रहा है दैट मींस यू हैव वेस्टेड द एंटायर एफर्ट यहाँ पे मेरा एफर्ट चले जाएगा पूरा पढ़ाने का सेम वे अगर आप आपके पेरेंट्स का करो तो आपके पेरेंट्स का एफर्ट पूरा चले जाएगा कि हमने इतनी मेहनत करी सब कुछ दिया आपको गाइड किया आपके लिए पैसा इन्वेस्ट किया आपके स्कूलिंग में कॉलेज लेवल पे बट इतना सब स्पेंड करने के बाद भी आप अगर कुछ आउटकम नहीं निकाल पा रहे हो then it is the problem in the system okay और वो सिस्टम ज्यादा टाइम तक चलेगा नहीं वो कोलैप्स हो जाएगा कहीं ना कहीं so it's preferable that whenever you come to the class not for physics only but any class you come or go you just try to make some outcome from that okay कुछ आउटकम आप निकालो उससे ताकि आपका जो पढ़ा है जो कंटेंट है वो वर्थ हो जाए so that's how this laser light we are getting over here so I hope now everyone can relate this example from I mean their daily life. Still, if someone is having any doubt, please let me know. We'll try to clear that. Is there any doubt?
Sir, when the electrons they transfer from the second level to the first level,
yes.
laser beam is emitted. So
yes.
that would mean that from N2 to N1 there is a stimulated emission because the laser light is produced.
Yes. And even the number of particles are higher in the level number 2 compared to level 1.
So if it is a stimulated emission, then we need to first of all supply that energy so that the electron transfers from N2 to N1 by giving out the energy.
Yes, and that is why I told you in the beginning that this level difference which you see N3 and N2, level 3 and level 2, it is not that much large, it is very small. So almost same amount of pumping energy can be useful to trigger the levels which are there in the level number 2 to come down to the level number 1. Are you getting that?
Yes, sir.
Yeah. Yes.
While jumping from level 1 to level 3, there is very low probability, no, to jump to level 2 and then to go to level 3.
Yes. So that probability is less. Of course, it is there that it can jump from level 2 to level 3, but the probability is again very less. So we are neglecting it.
Then, sir, there could be the case, no, that directly the electron will jump from 3 to 1.
That also be there. I am not denying it, right? But there are certain things. Okay, these are not the arbitrary or let's say randomly happening things. There are certain patterns which is there for the atomic level. Okay, so all such rules, basically there are some rules which this energy level says to follow. Some scientist has provided the rules. According to that, only the transition can possible. Okay, so when we really go to the actual system, maybe in the case of helium neon laser, that time I will explain it to you this concept that 3 to 1 theoretically तो possible है. I cannot deny it, no doubt. But practically वो possible है कि नहीं है वो मुझे देखना पड़ेगा. ओके, सो लेजर का जो सिस्टम है हीलियम नियॉन का, उसके अंदर हमने यही वाला पूरा जो पार्ट है वो कवर किया हुआ है कि भाई 3 से 1 में पॉसिबल है तो क्यों नहीं हो रहा है, उसका रीजन क्या है. क्लियर? सो डोंट नीड टू वरी, आई एम हियर टू एक्सप्लेन यू एवरीथिंग रिलेटेड टू दिस लेजर. Okay.
Sir, regarding the previous question that was asked by someone,
Yeah.
like for the laser light to be produced, like in this case, it is stimulated emission. The energy that the particles will need that are in E2 that will be produced like when they are coming down from E3 to E2, right? So that energy released will be useful for them to get down in E1.
Yeah, E3 से E2 only for some, as I said, it is in form of heat only. Okay.
Yeah, so that heat energy is acting as the source for the particles in E2 to get in E1.
No. Heat energy cannot be involved. I mean, heat energy is there, but it cannot trigger the particle to go to the lower level. Okay, so heat energy केवल surroundings के साथ exchange हो जाएगी. That's it. उसका और कोई काम नहीं है.
So then what is the trigger for particles in E2 to come down to E1?
Same pumping frequency, because this pumping is going on. You are not stopping this pumping. This pumping is going on. Okay, so as I said, that whenever you supply the energy, so equal probabilities are there. It can interact with the lower level also. It can interact with upper level also. So the moment it interacts with upper level, and that is why I told you that this level 3 and level 2, in diagram it seems to be a large difference, but in practice this energy level difference is very less. Okay.
But sir, if we are
Yes, sir, got it.
at level 2, then they should jump to level 3, no? If we are pumping continuously and they are triggered to go down, then they should jump to level 3, right?
Yes.
Because we are supplying more energy. Then why are they coming to level 1?
No, they are not coming to level 1. If you are supplying energy to the level 3, fine, they are there, but they can stay only for a certain time according to their lifetime of that level. Clear? As I said in the example, कि अगर आप स्कूल में जाते हो, आप पहले पहुंच गए 15-20 मिनट पहले कितना भी पहुंच जाओ, लेकिन आपको 7:30 बजे आपको क्लास के अंदर इंटर होना है, तो दैट इज व्हाट यू कैन इंटर इनटू द क्लास, बट क्विकली आपको करना है. सपोज कोई अगर उसमें ऐसी इट इज अ टाइम विंडो, अगर मान लो कोई बिल्कुल 7:25 7:28 पे ही क्लास स्कूल में पहुंचता है, तो उसके पास केवल 2 मिनट का ही टाइम है कि वो तुरंत क्लास में पहुंच जाए. So that is what this is the narrow window where the lifetime of that level is very less. IR photon नहीं होगा, IR photon का केस अलग है. ओके, so this is just heat. फोटोन कब होगा? जब वो बोलूंगा जब वो एमिट हो. ओके, सिस्टम में कोई रोल पार्टिसिपेट कर रहा है, यहाँ तो केवल एनर्जी एक्सचेंज हो रही है. ओके, केवल हीट के फॉर्म में, तो दैट हीट आई कैन नॉट कंसिडर एवरी टाइम एज ए IR photon. Any other doubt?
Sir, the laser emission then would be called spontaneous emission, no?
No, stimulated. Spontaneous नहीं है. Spontaneous है तो आपका random लाइट निकलता है, मतलब कि डिफ्यूज लाइट जनरेट होता है. तो अगर आपको लेजर चाहिए तो स्टिमुलेटेड लाइट, आपको स्टिमुलेटेड एमिशन प्रोसेस करवाने पड़ेंगे.
Okay, sir.